Hello everyone, welcome back. Mr. Avel here, going over 9.5, which is parametric equations. Okay, so here's a nice video that you can watch. If you notice, he likes to say parameter a lot. So good video though that you can watch. We'll watch it in class if you missed it. So these, I decided to write them out, a couple of these key terms. You can pause the video if you need some extra time to just jot them down. Okay, so a parametric equation is an equation where x and y are defined in terms of a third variable, okay? And that's usually t or time, right? So if you think about maybe like a baseball getting hit, you can follow its path like this, right? You have an x and a y coordinate for each of these points, but a lot of times we want to know at certain times, right? So what about, what is it when t is equal to 1, right? So we can figure out the value at certain times. You'll notice that in our parameters, we'll use, parametric graphs. You'll see a lot of times we'll put these arrows, and those arrows follow the direction according to time, okay? So that's a parametric equation. The parameter usually is that third variable, which again is usually time, okay, which is the t value. And then the plane curve, it's just a set of ordered pairs like x and y, okay, where x is a function of time and y is also a function of time on the interval I, right? So again, in math, pure math, right, you would have a parabola that would, like our baseball there, that would go on forever, right? But in real life, the baseball doesn't go on forever. It has a starting and a stopping point. So that's going to be our interval there. Okay, we can graph it on a coordinate system. And as I said before, the arrows are going to follow your time. Cool. All right, so our first example here, it says graph the plane curve defined by the parametric equation below on the interval. So this is our interval. One way to kind of think about it is kind of your domain restrictions, right? Kind of what we used to talk about with your restrictions on that. So we've got an x value with relation to t, and a y also relation to t. And so what we could do is just set up a table here with t. And so we're just going to start at -2 because that's where they want us to start. -1, 0, 1, and 2, okay, based off of our interval there. So our x value is equal to t squared minus 1. So in this case, we have what? -2 squared minus 1, which is equal to 3. And I'll do maybe one more, and then I'll let you guys do the rest of the calculations. But -1 squared is 1, minus 1 is 0. Now if I plug in 0 for t, for the x portion of it, I get -1 back. If I plug 1 in, I get 0 back. And then plug 2 in, I get 3 back. Okay. Now I'm going to do for the y as well. This is 3t. So this one would be -6. 3 times -2, then 3 times -1, 3 times 0, 3 times 1, and 3 times 2. Okay. And so that's the idea there. And so all you're going to do is on your coordinate plane here, you're just going to plot those, right? So for our first point here, we've got 3, -6, 0, -3, -1, 0, 0, 3, and 3, 6. Cool. So if I plot that, that's 3, -6, 0, -3, -1, 0, 0, +3, and then 3, 6. Okay. And so on the interval, it follows this path right here. Well, bam. And so that's all our graph's going to look like. Again, since it's a parametric equation, we want to know which direction whatever is going. The baseball, the car, whatever it is. So according to our time, it's going in this direction. So the bottom this first point right here was my my starting point, and this was my ending point. So we put little arrows to show which direction that this graph is going. Cool. And that's it. Now this next one is very similar. Okay, and so it says here, gives you x was root t, and y is equal to 2t minus 1. It says solve it by eliminating a parameter. Okay, so use your table to verify your work. So here, one thing that we want it to be, again, kind of like a real life situation. So for t here, that guy gives me a good hint that I don't want negative, right? So I don't want negative time because it would start giving me imaginary numbers, at least for the x portion, right? And so here we know that t is going to be, we can have 0, but it's going to be greater than or equal to 0 on that one. Okay. So now there's a few ways to go about this, but the idea is I want to get rid of the t portion of it, right? So I want to get rid of that parameter, the t. And so in order to do that, I'm going to use substitution. So if I look at my two equations, they both have a t, but one of them has a square root of t. So in order to get that square root out of there, let's square both sides, right? So I have x squared is equal to t. And now what I could do is plug the t portion into my other equation there. So I get y is equal to 2 times x squared minus 1 by substituting in. And so my final equation, simplified a little bit just without our parentheses, would be 2 and then x squared minus 1. Okay, so kind of our steps that we want to do here is we want to isolate. It's kind of like we did elimination and substitution with our systems before. So isolate the t in one equation. Okay, substitute that guy in. So sub in. And then once we've done that, we want to solve or isolate for the y. And kind of that's how we're going to eliminate one of the parameters. So now once I have this, we can go through and I can plug it in, right? So as long as t is greater than 0, so if I plug this into the first one, it starts where x is 0 and then grows, right? So if you look, this is just a parabola with a vertex of 0, -1 in HK form. So go down -1. And it's got a vertical stretch of 2. So normally I go over 1, up 1. So I'm going to go over 1, up 2. Again, normally I go over 2, up that squared, which is 4. But because of my stretch, I'm going to go up 8. So that is 6, 7, something like that. Cool. And so the only restraint I have is that the time needs to be greater than 0. So I'm going to start here and shoot up. And it's going in that direction. And so that would be my parametric equation graph there. Okay. And here it says use a table to verify your work. Again, I might let you do that one there. We can go through, I'll start it for you, but if you have t, in this case 0, 1, 2, ... Our x is root t. So if I plug that in, our x is 0. And then our y here is 2t minus 1. So if I plug in 0, I get that, which is our starting point. If I plug 1 in, I get 1. Plug 1 into my y value, or my y equation, I get 2 times 1, which is 2, minus 1 is 1. And so I get this next coordinate point there. Okay, so you could keep doing it 2, 3, 4, 5, 6, as far as you are excited to do. Okay, all right, so number 3 here, it says sketch the plane curve represented by the parametric equations below by eliminating a parameter. Okay, use a table to verify your work. So this one's a little bit trickier, right? And so if you look, we've got our interval set up. That right there kind of gives me a hint that maybe I'm dealing something with radians and stuff like that, okay? And so what I can do is I can solve these guys, right? Or not solve, but let's try to isolate the t value. So divide by 4, right? So I have x over 6 is equal to cosine t, and then y over 4 is equal to sine t. So now this is where it gets a little bit tricky, right? So do I do sine inverse and cosine inverse to get the t's alone? That's a possibility, but then I wouldn't really know what to do with myself after I had that, right? So I don't know t is equal to cosine inverse of x over 6. I wouldn't really know what to do, okay? So one idea with something like this is if I take these two guys, right? And what do I know that we use quite a bit, especially in chapter 5, the good old days of chapter 5, where I can kind of eliminate those, right? And so if you think, if I square both of them, so if I have, I'm going to reorder it just so it looks like one of our identities. So sine squared plus cosine squared t, right? So that guy we know from good old days of Pythagorean identity, there is equal to 1. So now I can use this information and substitute into both of them, right? So if I square this guy, I end up with y squared over 16 plus square that guy. This guy's going to be what? X squared over 36 is equal to 1. Now this, think back to previous sections in this chapter. This is one of our graphs, right? So this is going to be, since it's an addition with it equaling 1, this is going to be an ellipse, right, with our major axis, in this case, in the x direction, okay, because the big number there. So if I take square root of 36, come out to 6, and then go back 6, because we're centered about 0, 0. And then in the y, it's 16, so square root of 16 is 4 and 4. Okay, so I'm going to draw this. Okay, maybe don't draw it, just listen for a second. So I'm going to draw this guy, my ellipse, and so very beautiful. Now I want to refer back to my interval. So my interval says from pi to 2 pi, right? So if we think back to our unit circle, we have 0, pi over 2, pi, 3 pi over 2, and then we come back here to 2 pi. So that just tells me, really, I just want the bottom half of this ellipse. So I'm going to keep just the bottom half of the ellipse just because of that interval. And so going from pi, we're going that direction. So we're going to draw our arrows going in that direction. Cool. You don't have to have a certain set of like arrows per square inch or anything like that. Just make it so that we can actually see which way the arrows are going. Again, you can set up the table here. So if you set up time, the x value, your y value, in this case, some of our big values that we want to know are going to be at pi. 3 pi over 2 is a good one, and 2 pi. Of course, you could do all the intermediate values, but it's really hard to tell something like, 5 pi over 4. I wouldn't really know where to graph it there. So these are the big ones. So x in this case would be -6 because we plug it into this. So cosine of pi would be -1. -1 times 6 gives me -6. And this would give me 0. Okay. And then 3 pi over 2 makes a sine -1. So this is -4 here and 0 here. And then kind of the opposite for that guy there. And what do you know? It matches our points that we have. Cool. Okay, couple more. It says find the set of parametric equations for the parabola. Okay, so this one's kind of a funny one. So what it's saying is we kind of want to go backwards from what we were doing maybe on number 2, where we had 2 equations with t involved. Well, how can I kind of work backwards to introduce t into number 4 and 5? Okay, so the best way and the easiest way you could do this is you're just going to say, let's let x equal t. Right, so I'm just going to say x is equal to t. And you can make it as hard as you want, but in my opinion, this is kind of straightforward. And so you're making up your own parametric equations. Well, so let's look back to here. If x is equal to t, my y value is going to be 9 minus t squared. And so these would be my 2 equations right there. Those would be my parametric equations. So if I go through this guy here, we don't really have, it hasn't told us really any constraints, right? So, or any restrictions. So I'm going to just start with some values, but it hasn't given us any restrictions. So I'm just going to do -2, -1, 0, 1, and 2. Okay, and we can show that they didn't give us restrictions by the arrows. Okay, and so here x would be super easy because it just matches your t value. And then your y, we're going to do 9 minus t squared. Again, I'll show you one of these, and then I think you got it from here. So that would be 9 minus 4, which is 5. So if I keep doing that, we've got 5 here, 8 for -1, 9 for 0, 8 for 1, and 5 again. So if I follow this at -2, I have -2, I have, is it 5? Yeah. So 2, 5. This one's at -1, 8, 0, 9, 1, 8, and 2, 5. So if you notice, it looks like a parabola. Okay, so now on the ends, we're still going to have, even though that on this, especially on this left side, it's not going that direction, right? So I started with the negatives, but this arrow shows that the graph is going to continue on. But parametric wise, my arrows go from negative to positive, so my arrows will go this direction. Okay, that's a little difference there to make sure we have the difference between the graph continuing on and the arrows for the parametric equation. Okay, so the last one here is super duper similar to the previous one, so make it easy on yourself. So I'm going to say let x equal t. Okay, well, if x equals t, then y is equal to t squared minus 25. Set up a little table, x and y. We're going to do -2, -1, 0, 1, and 2. So if I plug in, again, these guys are super simple because they match each other. And now a little bit harder here. If I plug in -2, I get -2. Make sure you got parentheses. So 4, so -21. Okay. And then if I keep going, plug this one in, I get -24. This one's -25. This one's -24. And this is -21. And kind of looks very, very similar to number 4 with our parabola again. Okay, so this one's a little bit, you'll notice the graph is a little bit off here, but that's okay. Let's maybe rewrite it here. So let's say, what do we need? We need to get down to 21. So we'll call this guy, what would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what if I did every, what, 2s? 2, 4, 6, 8, 10. So -10. 2, 4, 6, 8, -20. Okay, and so it's still a little bit beyond. Maybe let's change this. Change it one more time. So we'll call this one, sorry about this one. Okay, so this one will be negative 25 here. Okay, and so how would that work? So it's like 2.5-ish on each one, I think. And so after 5, 10, so this one might be like a 15 here. Negative 10, negative 5, 0, negative 20. Okay, a little bit hard to see, but that's okay, right? So at negative 2, we get negative 21. So negative 2, negative 21, which is exactly right there. Negative 1, we get negative 24. Exactly right there. Shabam, shabam, shabam. Okay, and again, this is our beautiful parabola. And again, the green arrows tell you that the graph continues, but our graph went this direction, from negative to positive. Okay. All right, well, I hope you enjoyed that. And that's the end of chapter 9. Tell a friend, and we'll talk to you later.